Let's have a quick recap of equations. And I guess basically what you're trying to do with an equation is make whatever it is you're trying to find the subject of the formula, if you like. If you think of it like a formula, isolate it by itself. Some people look at equations and just say, oh, I'll do the opposite, and so it's +3, I'll subtract 3, and I sort of do that. I actually try and visualise it as moving things. So I've got this +3, I don't want it with the x because I'm trying to find x, so I want to move it to the other side. And the rule is when I move something, I change its sign, so when it appears on the other side, it's now -3. Now, of course, it has exactly the same effect of subtracting from both sides. It's just a different way of thinking about it. So 6 minus 3, of course, 3. 5z, to undo the 5, we divide by 5, but we don't normally write division because, in fact, that's what a vinculum is, if you think about it. Did you know that's why the symbol division is what it is? It's a vinculum with a numerator and a denominator, but they are dots in the division symbol. And that's where the division symbol comes from, because of course divisions and fractions are exactly the same thing. But we do it this way because we get the answer straight away. If it doesn't simplify down, I don't have to do anything. Well, in this case, it does simplify down. We get 9. You have a choice here. You could divide first, then move a term, or you could expand out. It's really up to you how you do it. Which way did I do it? I expanded out, move the 20 over, so I'm adding 20, I get 36. Divide by the 4, we get the 9. And then of course we move to, oh, hang on, whoa, pronumerals on both sides, what am I going to do? But I want to get all the z's together, I want to get the numbers, so I'm going to be moving the 2 over to the right, I'm going to move the z to the left, but when I move them I change the sign, so we get 2z is -11. In this case I leave it as 11 on 2. Who would change that to 5.5 just out of interest? Anyone out of habit? We got a couple? Yeah. See, I mean, I don't. I personally leave them as improper fractions because they're the same thing. I mean, the same value. I guess it comes down to what you're doing with the answer. I mean, if the question was something like, I don't know, how long is this rectangle? Yeah, okay, 5.5 would make more sense than 11 on 2. So that would make more sense. But if I'm just finding the value, 11 on 2 is a perfectly good answer. Oh, no, pronumeral in the bottom of a fraction, what do we do? Well, we want to get rid of the fractions, so we multiply everything by the lowest common denominator. How do we find the lowest common denominator? If it's not there, put it down. So in this case, 7y, I'll be multiplying everything by. So we get 5 plus 14, 21y. 19 on 21 eventually becomes. The classic fraction equals a fraction. You see that situation, you save yourself a bit of time. Just cross multiply through the equation. So if you've got fraction equals fraction, it's that specific example, we just cross multiply. So the x plus 3 will be times 3, the 2x minus 6 will be times the 5, and then we just deal with what we end up with. So I'll probably move the 3 to the right, I would imagine, try and keep the x's positive. But even though I've moved it to the right, I've written it on the left. Because of course it doesn't matter, it's an equation. So in the actual moving, I really had 39 equals 7x. But that's not how we answer an equation, because the equation is saying what is x. So we answer it as x equals this. I wouldn't answer it as 39 on 7 equals x. Oh, that's fantastic, that's what 39 on 7 is, but what's x? So grammatically, it's better to say x equals. And there you go, quick one for today. That'll do us.